So inverse of quadratic functions. Last class, we were talking about inverse. We went through how to figure out the inverse of something if I give you the graph, how to figure it out algebraically by switching the x and y, and we just introduced the topic. Today, we're going to specifically, because this whole unit is on quadratics, right? It's all about the parabola. So we're going to talk about the inverse of a quadratic function. I have tried to really make it very easy in terms of like the way it's formatted, just so you can see where we're going with it. So we're going to try that. We're going to begin by looking at the first question, which is f of x is equal to -2 bracket x minus 1 squared plus 5. It is in vertex form. Go ahead and graph the original by using the step pattern. You don't need to use a table of values for this. Okay, so we're going to move 1 to the right and up 5. The negative sign means our parabola is opening downwards. And the 2 means that there is a stretch. So instead of the numbers 1, 3, and 5, we're going to multiply all of those by 2. And we're going to get 2, 6, and 10. And you just have to include as many as you can. Also, now that we're graphing the inverse, and now that we've learned function notation, if you want to label your graph with just whatever the function notation is, like f of x, that's more than okay, because that tells me that you're referring to the equation. So that's sort of the benefit of function notation. You don't have to write as much anymore. Like you don't have to write the full equation. Okay, the second part of this question says graph the inverse. Now we practiced doing this in yesterday's class. If I have a graph already, how do I find the inverse? Eli? Yeah, so we're going to take each one of the points. So I have a point here, here, and here. You can either make a table of values, write them down and flip them, or you can just do it in your head. And then you're going to graph those. So again, I'll show you the strategy that I use when I'm doing this. I just start at one side. So let's say I'm going to -1, -3, which is, oh crap, sorry, -1, 3, which is that graph right, that point right there. I switch those, and so I'm going to be graphing -3, -1. So right here. My next point is this one here. It is at 0, 3. When I switch those around, I'm going to be graphing at 3, 0. Then the vertex here is 1, 5. Switch those, you're going to be graphing at 5, 1. I realize you can't really see that color. Okay, then just keep going. So 2, 3 becomes 3, 2. 3, -3 becomes -3, 3. You might have to flip your page around. And another thing I put on my graph is I know that the inverse is reflected upon the y is equal to x line. So I usually show that with a dashed line. It's just the line that's like 1 up, 1 to the right, 1 up, 1 to the right. So you can go ahead and draw that in as well. And I'm going to label this y is equal to x. So I'll pause here. I'll give you guys a second to do this. All right, so we have this shape now. We have to answer, is the inverse a function? So does it pass the vertical line test? No, it doesn't. So remember yesterday's class, we were talking about how to label stuff like this. Can I use this notation to label my function? No, because it's not a function, it is a relation. So remember the little cheating way I taught you? You can go ahead and just use this. It's not official, but I feel like it helps us distinguish between if something is a function or not. So anytime I use y, that means it is not a function. Well, yeah, yeah, or you can find the equation and put that. Yes. Yeah, you could. Yeah. Okay, the next part of this is asking us to figure out the equation of the inverse. So this is good review of what we learned last class. What we're going to start by doing is replace the f of x with y. So it's going to be y is equal to negative 2 bracket x minus 1 squared plus 5. This is also good review if you weren't here yesterday, so we can kind of go over what we did. You're going to swap the x and y. So it's going to be x is equal to negative 2 bracket y minus 1 squared plus 5. We are now going to move things around and isolate for y. So I am going to move the 5 to the other side, and I'm going to divide by negative 2, all sort of in the same step. So it's going to be x minus 5 divided by negative 2 is equal to y minus 1 squared. Now, I personally don't like when my variable's on the right, so I'm just going to rewrite it so the variable is on the left, but it's the exact same thing we just wrote, except I'm going to put it as y minus 1 squared is equal to x minus 5 over negative 2. How do we get rid of a square? You take the square root, but when you take the square root of something, what do you have to remember to also put? Yeah, so for example, if you have like y squared is equal to 4, that's supposed to be a 4, you actually have to write y is equal to plus or minus square root 4, because this answer can be either plus 2 or minus 2, right? 2 times 2 is 4, but negative 2 times negative 2 is also 4. So we have to make sure that whenever we have a square and we're taking the square root, you include both the values. And especially for this topic, this is really important. And when we do the next page, I'll show you why. So when we take the square root, we're going to go y minus 1 is equal to square root x minus 5 over negative 2 plus or minus. And then we just need to move the 1 over, so the negative 1 will become a positive 1. I kind of ran out of room, so I'm going to do that in the same step as well. So it's going to be plus 1. I also want to remind you that that plus 1 does not go under the square root sign, so make sure you write it separate from the square root sign. Also, there is another way to write this. So remember last class, we were kind of talking about how you can, if you wanted to split that up, so you could write it as negative a half x plus 5 over 2 plus 1, whatever you want. But I'm just going to keep it as the one format that we have. Okay, so see that plus and minus sign? It is very important because the plus sign actually refers to the upper branch of the inverse. So see this plus sign? It refers to this right here. Oh, that's so much better. Thank you. And see this minus sign? It refers to that branch over there. And the second page outlines this, but I just want to point it out while we're on this question so you can kind of see where those different things are going. Okay, last but not least is the domain and range. And you're going to see something really cool happen when we talk about the domain and range for this question. So let's try and first figure out the domain. And by the way, you know how we do the full set notation? I don't have enough room, so all you have to write is the condition just for these questions. We'll just write the condition so that we're not wasting too much space. What is the domain of the original parabola? Every parabola, what is the domain? Yeah, so the domain is just going to be x includes all real values. And that's because the parabola keeps going in either direction forever and ever. There's no start, no stop to it. Okay, how about the range? So this parabola starts at 5 and then it goes below. How do I write that in proper function notation? y is less than or equal to 5. Perfect. Let's do the same thing for the inverse. So ignore the green graph. Now we're just looking at the reddish orangish graph. The domain is like from right to left. So this one starts at 5 and then it gets smaller and smaller and smaller. So how would we describe that? X is less than or greater than to 5. Yeah. And then for the range, it goes forever up and it goes forever down. So how would you describe that? If it goes forever in either direction, we would just say, y includes all real numbers. Okay, so the cool thing about an original function and its inverse is that the domain and range are actually interchanged. So we kind of touched upon this in yesterday's class. The domain of the original becomes the range of the inverse, and the range of the inverse becomes the domain of the range of the original becomes the domain of the inverse. This is useful because if I'm asking you a question about the inverse, really you just need to figure out the domain and range of the original and just flip them around, and you automatically have the domain and range of the inverse without putting in the work or actually looking at the graph. Any questions about this so far? Are we okay with it? Kind of? Okay. Let's try example number 2. It's more of the same stuff. So how about you guys try this yourselves? I'll put the solutions and then we'll discuss it. Do I want to be consistent with my color scheme? Sure. So -1, -3, 1, 1, 2, 3, 3, 1, 2, 3, 4, 5, 5. And then remember for the inverse, you're just looking at all the points and switching them around. So I have -4, 6, which is 6, -4. -3, 1, which is 1, -3. -1, oh no. This is -2, -2, which was the same thing. -1, -3, so that's going to be -3, -1, 1, 1, which is going to be this number right here. I feel like I messed up here. Hold on, let me try this again. So we have -4, 6, which is going to be 6, -4. Then we have -3, 1, which is going to be 1, -3. Then we have -2, -2, which is right there. Then we have -1, -3, which is going to be -3, -1. That's right. Okay, we're back. 0, -2, which is -2, 0. 1, 1, and then 2, 6, which is 6, 2. That's much better. And then make sure you draw in your y is equal to x line, just so that you can see what it is reflecting upon. Did you guys get the same kind of graph as I did? Yeah, it kind of like, you can see it sort of flip over. Hopefully you recognize that the inverse is not a function. And so when you're labeling it, you can't use f, you have to use the little cheating code that we have there. And then you are going to be writing the equation of the inverse. So I'll do that here. So y is equal to x plus 1 squared minus 3. X is equal to y plus 1 squared minus 3. x plus 3 is equal to y plus 1 squared. I'm going to take the square root of both sides. So it's y plus 1 is equal to plus or minus root x plus 3. And I guess I can just write it here. Y is equal to plus or minus root x plus 3 minus 1. By the way, I should have, in the original question, make sure you write down what, like, I didn't write down the little -1 to show that it is the equation of the inverse. So I should have written y negative 1x. Okay, so I'm going to do that here. And I can't write f because it is not a function. And again, we have a plus and a minus sign. And in the next page, we're going to learn that the plus and minus sign refer to the two different branches of the inverse. Like one is for the upper branch and one is for the lower branch. All right. What'd you guys get for the domain? Well, the domain of every original parabola is going to be XER. That means, without even thinking, I know that the range of the inverse is going to be YER. And then the range of the inverse, what'd you guys get for that? Y is greater than or equal to -3. And that means the range is going to be x is greater than or equal to -3. Like it's long, but if we go on to the second page, now we're going to learn all of the rules of everything we've been talking about. So important information. What is this, a hippo? Oh, so cute. I don't know why his legs cut off, but the inverse of a quadratic function is defined by XER, and it is not a function. And we just learned this, that whenever you have a quadratic equation, a quadratic function like a parabola, you take the inverse is never going to be a function. If the original quadratic opens up, so if the original quadratic looks like this, then the inverse is going to look like this. Let's see if this was true. So go back to example number 2. See how the original parabola opens upwards in this? The green parabola is opening up. What happens to the inverse? It opens to the right. And that's always a rule. You can always know that any parabola that opens up, the inverse is always going to open to the right. The next rule, if the original quadratic opens down, so if it looks like this, the inverse is going to open to the left. So again, prove this to yourself. Go back to example number 1. In example number 1, the original parabola in the green opened downwards, and so the inverse opened to the left. So up is right and down is left, kind of like clockwise. The inverse of a quadratic can be a function if the domain of the original is restricted. And now this is the part that people get confused about. What exactly does this mean? This means that, let's say I'm forcing you to draw the inverse, but make it a function. I want to make the inverse a function. How can I do that? Well, what I can do is I can just look at one part of the original parabola. So I can just look at the left part or the right part. And I'll show you what I mean. So by the way, these are all parabolas that go on forever. If this is my original parabola in the red, okay, let's just take a look at the first example. And this is, by the way, the same 2 examples we just did on the previous sheet. So my original parabola is opening downwards and my inverse is opening to the left. And that makes sense, right? Down goes left. Now, if I want to make the blue line into a function, what I can do is I can just look at one part of the original parabola. So let's say I say for the original parabola, I only want you to draw the right-hand branch. So what I would say is in the original question, I would write it as x is greater than or equal to 1. So if you have a question where it gives you the function, but it gives you, this is called a restriction, it's asking you to only draw 1/2 of the parabola. And the reason why you would do that is if you only have 1/2 of the parabola, then that's going to give you only 1/2 of the inverse. So that part of the parabola is going to give you this part of the inverse. How did I know that? Well, there are specific rules, and that rule is written right here. The right branch of the original parabola, so the right-hand side, which is this right here, it gives you the positive square root of the inverse, which is the upper branch, and that's in the blue over here. So let's write that down. The right-hand side of the original, this side right here, is going to give you the positive square root part. When you take your inverse, you know how there's a plus or a minus? The plus refers to the top part of the parabola. Okay, the other rule is, let's say instead of x is greater than or equal to -1, I'm going to say, no. I only want you to draw x is less than or equal to 1. So that means I'm forcing you to draw this part of your parabola, just the left-hand side. And the rule is, if you draw only the left-hand side of your original parabola, that is going to give you the lower branch of your inverse. So if you were to draw just the left-hand side, you know what? Let's, can we like change the color of that? It's too close to the other one. Okay, whatever. That is going to give us this left-hand side of the inverse. And in the equation, this refers to the negative square root answer. That's a lot to remember. That's a lot to like think about and almost like memorize. But let's do one more example and see if it makes sense. So again, in this question, I have my original parabola in the green, and then if the original parabola opens up, then the inverse opens to the right, which is this way for you guys. Okay, so up and right. So if I wanted my inverse to be a function, I have to restrict the domain. What that means is, let's say in the original question, I said, I only want you to draw x is greater than or equal to -1. So what that means is, I only want you to draw this right-hand side of your parabola. And if you're drawing just the right-hand side of the original parabola, what part of the inverse is that going to be? The upper branch or the lower branch? Good, it's going to be upper branch. So that means we would only be drawing this upper branch. And in your equation, you would only write the positive square root, not the plus and minus, just the positive. Okay, how about if I change the question and I say, no, now I want you to only draw when x is less than or equal to -1. So I only want you to look at this left-hand side of the branch. If you're drawing only the left-hand side of your original parabola, what part are you drawing in your inverse? Good, so then you'd be drawing just the lower. And by the way, if you're only drawing an upper or lower branch, does it pass the vertical line test? It does, right? Then it's not failing the vertical. Like if you're only looking at the dark pink or light pink graph, that does pass the vertical line test. And so then your inverse is a function. So that would be the negative square root. That's a lot. Let's actually practice a question, but make sure you guys understand these rules, because I could ask you theoretical questions about this, right? Like on the unit test, I could say, if I only draw the right-hand side of the original parabola, what is that on the inverse? So you should know the right-hand side of the original is the upper of your inverse. The left-hand side of the original is the lower of the inverse. Okay, let's try a couple of questions. So practice questions. Question number 1, and we're just doing this page and then we're going to be done. So question number 1 says, given f of x is equal to -2x squared plus 8x minus 7, I want you to determine the equation of the inverse. Can we, okay, if we were to just start this question, we would say, all right, y is equal to -2x squared plus 8x minus 7. Don't write this down. X is equal to -2y squared plus 8y minus 7. I have 2 y's. Can I easily isolate for y in this case? If I have 2 different y's, I can't. So what we have to do is we always want to try to get the question into vertex form. How do I go from standard form into vertex form? Good. So I'm going to have to first complete the square, get it into vertex form, and then find the equation of the inverse. This is good practice. I feel like completing the square is always good practice. So I will say it along just in case you still need like a little bit of review. I'm going to group the first 2 terms together, and I'm going to factor out the -2. So it's going to be -2 bracket x squared minus 4x minus 7. Then I'm going to take the 4 inside the bracket. I'm going to divide by 2. That's going to give me a 2, and I'm going to square it. So it's going to be -2 x squared minus 4x plus 4 minus 4 minus 7. I'm going to factor that, and I'm going to get x minus 2 minus 4 minus 7. I'm going to distribute that, so it's going to be negative 2x minus 2 squared plus 8 minus 7. And then my final answer is going to be f of x, or y, is equal to negative 2 bracket x minus 2 squared plus 1. I'll pause here just so you guys, if you're still. Okay, we are now ready to figure out the equation of the inverse. So remember, you replace the f of x with y. It's y is equal to negative 2 x minus 2 squared plus 1. And I think we've done enough practice on this, so hopefully you guys are getting the hang of it. We replace the x and the y, so we're going to get y minus 2 squared plus 1. I'm going to move the plus 1 to the other side and divide by negative 2, so it's going to be x minus 1 over negative 2 is equal to y minus 2 all of it squared. I'm now going to take the square root, but I'm also going to flip everything around. So it's going to be, my final answer is going to be y is equal to plus or minus square root x minus 1 over negative 2 plus 2. And because I want to make sure that I know that this is an inverse, I can't use function notation because we know the inverse of any parabola is not a function. I have to use y negative 1x. Okay, so nothing new here. We all know how to complete the square already. We practiced finding the equation of the inverse a lot. We know how to do this. Question B is the new part of this lesson. How can the domain of the original function be restricted so that the inverse relation is a function? So to answer this question, I want to begin just by sketching it out. I want to see what this graph actually looks like. So let's draw a quick sketch of it and see what exactly is happening here. Okay, so a sketch means we're just not going to be very accurate. We don't have to put in numbers and stuff. Negative 2 means we're going to go 2 units to the right. And up 1 means we're going to go up 1. It's negative, so it's opening downwards. And there's a little bit of a stretch, so it's going to be a little bit narrower. By the way, if the original parabola is opening down, which way is the inverse going to be opening? To the left, right? Down, left. So without even like doing anything, I know the shape of the inverse is going to look something like that. It's going to open to the left. Okay, but that's okay. That's not what the question's asking. It's saying how are we going to restrict the domain? So what we can do is we can either look at the left side of the original or the right side. So there are 2 different ways to restrict the domain. Either one of these answers is correct. If I ask you just for one way, you can write either one of these. So let's say we are just looking at the left branch. So the left branch is this one over here. If we were looking just at the left branch, we would say we only want to draw the domain when x is, what do you think? How do you just describe the domain of this part, Niloy? Exactly. So if in the original question, I wrote down x can only be less than or equal to 2, then you're only looking at the left part of the branch, and that's fine. Then I would know I'm only drawing the left-hand side of the branch, not the right. And then when I draw the inverse, it will be a function. Nope, it doesn't matter which one you choose. So that's one possible answer. Yep. This is literally it. I mean, the diagram is really just for you to see where the domain and range would be. You don't even really need to write. Yeah. And then another suitable answer is if you're looking at only the right branch of the original. And if the question said, tell me both of the restrictions, then you would have to write both of them. If I just said, tell me a restriction, you could pick and choose. So for this part, I would only be looking at this side. And what would I write in the original question? I would write, I want to draw this parabola only when x is greater than and equal to 2. And that tells me I'm only drawing the right-hand side of the parabola, and that means I'm only going to draw the upper branch of my inverse, and it will be a function. Does this make a little bit more sense when you actually do an example? Okay. Question? Oh, okay. Last question. All right, last question. Given f of x is equal to 3 bracket x minus 1 squared for x is greater than or equal to 1, determine the equation of the inverse. Okay, so see this right here? They have given us a restriction. So if we were to graph this, would we be graphing the entire parabola, or would we be graphing only one part of the parabola? Just one part. Okay, so let's go ahead and draw our sketch to see what that would look like. So we're moving 1 unit to the right, and that's it. And the 3 means there's a stretch. And technically, this parabola, don't copy this down, but this parabola would look something like this, right? The parabola would. However, they have said they only want the parabola when x is greater than or equal to 1. So what are we actually going to be drawing? We're only going to be drawing from here up that way. So just the right branch of the parabola. Yeah, okay. So now what exactly does this mean? They're telling us to find the equation of the inverse. So we're still going to do the same process. The only part that's going to change is we're not going to write plus and minus anymore. We're only going to write what number. If you're looking at the right side of the parabola, that means the inverse is going to be the upper branch or the lower branch. Yeah, so go back to these rules. The right branch of the parabola gives you the upper branch, and the upper branch means you only have to write the positive square root part. So that's really, it's such a little different. It's such a small little thing that you have to do, but it really makes all the difference. Okay, so to finish off this question, let's figure out the equation of the inverse. We're going to go y is equal to 3 bracket x minus 1 squared. X is equal to 3 bracket y minus 1 squared. I'm going to divide the side by 3 and move everything around. So it's going to be y minus 1 squared is equal to x over 3. I'm going to take the square root of this. And in the past, when we took the square root, we would write plus and minus. X over 3 plus 1. However, because the restriction is telling me to only look at the right side of my original, that means when I draw my inverse, I'm only looking at the upper branch. So you only have to include the positive side, not the negative side. In fact, if you did include the negative, it's a big mistake. You would get a whole mark off because you don't understand the question, what it's asking. So the sign really does matter. By the way, for this question, can we use function notation? Because if we're only looking at one branch and we're only drawing, if it opens up, it's going to the right. So it's going to look like this. Is that inverse going to be a function? Yes, it is. So for this question, you definitely have to use f negative 1x. And again, that's a small detail, but if you were to use y negative 1, you would get a whole mark off. Because again, that tells me that you know that the inverse is a function or not. So those teeny tiny details will add up. You have to be super careful with these questions. Okay, any overall questions? You probably are like needing to do a little bit of work. You are going to be working on handout C and page 161, numbers 1 to 11. I'm going to stop right here.